We've been talking about heavy-tailed distributions and the problems that can arise if there are a huge number of rare events that can cause life-critical consequences. But how does this relate to automated vehicle safety? Here's how it works out. The difference between driver assistance and automated driving illustrates the problem. When you have a driver assistance system, this means the human driver is in control of the vehicle, in charge of safety, and they may turn on some automation to help them drive, something like cruise control. But when the cruise control makes a mistake, it's the human's responsibility to clean up the mess, and the assumption is made that cruise control will get out of the way when the human wants to override it. If you have an active safety system, such as automatic emergency braking, the presumption is that the automatic emergency brake will not activate unless a crash is more or less inevitable. That means that if the automatic emergency brake activates and prevents a crash, it's the hero. It saved a life. If it fails to activate, well, the driver was going to hit something anyway. So really, it's the driver's fault, and the driver assistance system gets credit for saving the driver. But if it doesn't activate, well, the driver was going to crash anyway, and so even if you're imperfect, even if you're 90%, 95% proper activation, as long as you don't have false alarm activations, in other words, you have a low false positive rate, then you're the hero. This means driver assistance systems are tuned to have low false activation rates, and when they activate, they get credit. That type of situation is tailor-made for the left-hand side of a long-tail curve. It only needs to deal with the common things, and it gets credit for the common things, and something really bizarre and uncommon, if it doesn't activate, well, that was the driver's fault anyway. Let's contrast this with automated driving. In automated driving, the emphasis is not just on providing safety when it's easy and you have already seen the problem. It's on scenario completeness and coverage. The automated driving system has to do everything, because the entire point of being automated is that you're not relying on the human driver to save the system if something goes wrong. That means you need sensor fusion, perception, and prediction to be essentially perfect. But what if an automated driving system is imperfect? What if you hit something out in the heavy tail that you've never seen before, the design team never saw before, the design team thought was impossible, but in fact it happens anyway? How's that treated? Well, the automated driving system's in charge of safety. So if it gets something wrong, even something that nobody ever thought of before, it's going to be blamed for the crash. In other words, it's going to be blamed for false negatives, not knowing about something out in the heavy tail, because its job is to be safe. That does not mean automated driving systems have to be perfect, but they need to be almost perfect to be able to attain the same reliability as a human driver. If an unimpaired human driver is having fatal crashes only once every 200 million miles, that means the automated driver has a lot of miles between times it's allowed to get something wrong, even if the something that happens is out in the heavy tail that it's never seen before during design, test, training, or even at a time during the system's deployment. In other words, for a driver assistance system, such as an ADAS, Advanced Driver Assistance System, it gets the credit when it saves a life, and if it has a hole, well, that was the driver's fault anyway. It doesn't get the blame as long as it doesn't falsely activate and cause a crash. On the other hand, automated driving gets the blame anytime there's a crash because the whole point is there's no human to save it from making mistakes. This means that safety for automated driving will be limited by how far into the heavy tail the design and test process can push, and by how good the system is at realizing it's in a situation it's not been trained for and doing at least something that's safe, even if it doesn't know how to handle it completely.